Good morning, class. So today we're looking at Trigonometry, chapter 5. This is dealing with compound and double angle identities. You derive the compound and double angle identities. In grade 12, you are introduced to new identities called compound angles or additional formula. Compound angle identities. There are 4 compound angle formulas. Okay? However, the first one is a proof. We spoke about this here. And if you want the explanation, you can find it in the description box below, labeled lesson 1. Okay, and the derivation of the rules. Okay, and there we go, there's all the proof there. So at this point, I just forgot to make a copy of this. For this first exercise, or the example dealing with the first exercise, we're going to break this up into 2 parts so that we don't give it too much information at once. Okay? So the examples we'll break into 2 parts, and the homework exercise, which is exercise 1, we'll also break up into 2 parts. Okay? You guys okay with that? Or you want everything at once? To do nothing with? No? Okay. We will be looking at the examples 4. And trigonometry, examples for exercise, exercise 2. Okay, exercise 1 was the revision exercise, no? Yes. So it's exercise 2 on page, examples for exercise 2, which is on page 95. Okay. Will probably be part 1. But here we are told that determine. Okay, before we go into this, at this point we have proven the formula which says cos of alpha minus beta is equal to cos of alpha cos of beta plus sine alpha sine beta. Okay, that is what we just proved now. Okay, there's a formula that we just proved. So the question says, determine cos of 90 minus beta using that formula. Okay, so where do we start? We started by writing the formula. Cos of alpha minus beta is equal to, what's the formula? Cos of alpha minus beta equals cos of alpha cos of beta minus sine alpha sine beta. Not so. So what we do is we say, okay, we got cos of 90 minus beta. Sorry? It's the plus. No mistake, it must be plus. Okay. So what will it be? Cos of, what is your alpha angle now? 90 degrees. So cos of 90, cos of beta plus sine. What is your alpha now in this case? 90 sine of beta. Okay. But what is cos of 90 minus beta to us? Sine of beta, not so? Alright. Let's see here. Cos of 90, we take it to the graph. The cos graph. This is, remember, 360. What is this point here? 90. Yes! It's 90. Not so? So, what is cos of 90? 0 times cos of beta plus. Sine of 90, we draw the sine graph. Sine. This is 360. What is this point here? 90. Corresponds with 1. So it's going to be 1 times sine of beta. 0 times cos beta is gone. The answer is sine beta. Then you just prove it now using that identity. That cos 90 minus beta is equal to sine of beta. Okay. let's carry on with the lives. To derive the other formulas, or formulae, use the formula cos of beta, so cos of alpha minus beta. Derivation of cos of alpha plus beta is equal to cos of alpha cos of beta minus sine alpha sine beta. Okay. So now, remember at this point we have proven this formula that says cos alpha minus beta is equal to cos alpha cos beta minus sine alpha sine beta. Okay. That's the formula that is proven. Now, we must derive the other three formulas from that formula. Okay, and this sum is worth 3 at times 4. 3 or 4 marks. Okay? I think it came in last year's paper or the year before. November 2023 or 2022. One of those 2 years it came in. It was worth 4 marks. And this is how we do it. Okay? So this is what they want you to prove. Can you see that? That's what they want you to prove. So we ask ourselves, okay, we need to prove cos of alpha plus beta is equal to this. But what do we have in our formula? Cos alpha minus beta. Not so. So how do I get this left hand side? Why left hand side? Because the left hand side is the equal sign. To look like cos with a minus in between it. Not going to affect your alpha, but how is that going to affect your beta? Sorry? How do we get from a negative to a positive? We times by a negative. Not so? Because negative times negative is of course positive. So have I changed anything here? No. So, but I also now conforms with cos of alpha minus whatever beta is, whatever that angle is. You guys see that? So in other words, that can be now written as cos of alpha, and what's my alpha angle? Alpha times cos of beta, and what's my beta angle here? Negative beta, yes. Plus sine, what is my alpha angle here? Alpha times sine of beta, which is negative beta. Okay. So we ask ourselves, okay? Reduction here. Which quadrant is that lying in? Which quadrant? In the fourth quadrant. Why? So your negative angle. For those of you who don't see it like that, what we normally do is we add 360 to it. What is 360 minus beta? It's in the fourth quadrant, which is just beta, not so cos of beta. So that cos is positive in that quadrant. So it's going to be cos alpha times cos beta plus sine alpha times. Which quadrant is minus beta in? Fourth quadrant. Or we say 360 minus beta. Remember, when I add or subtract 360 from an angle, I don't change anything. Not so. So what's 360 minus beta? In the fourth quadrant. You sign positive or negative? Negative. Which change this positive to a negative. You guys see that? So that is simply going to be a sine of beta. And of course can be written as cos alpha times cos beta minus sine alpha sine beta, and that is exactly what they wanted you to do. This one is worth 3 marks. Okay? 1 on the first line, 2 on the second line. Okay? Simple, huh? So do it again, or you guys understand? Understand, nice. What? Oh, Jesus. Alright, let's try. It's fine. I just hope you're not going to walk out during break, no? I don't mind explaining. Right. Derivation of cos of alpha plus beta. We must, at the end of the day, prove this here. Okay. To derive the other formulas using this formula. Cos alpha minus beta is going to be cos alpha, cos beta, plus, that's the formula we've proven, sin alpha, sin beta. Right. So remember, we must get this cos alpha plus beta looking like cos of alpha minus beta. Remember, the alpha and beta can be any angle, not so, can be anything. Right. So we go. The left hand side of this equal sign. So we got cos alpha plus beta. Now remember, what do we have here? We have a minus. So we must say, this will be cos alpha minus beta. Why minus? Because a negative times negative is a positive. Okay. What is my alpha angle here? Alpha. What's my beta angle? Negative beta. Can you see that? This is the minus. Okay. So the rule says if it's cos alpha minus beta, it can be written as cos alpha, which is alpha, cos beta. And what's your beta in this case? Negative beta. Okay. It's a plus. Sine, what's my alpha in this case? Alpha. And sine beta, which is negative beta. So as you can see, this is a reduction, is negative angles. Now coming back to grade 11, we say that if that's 0, this will be minus 90, minus 180 and so on. The beta angle, alpha angle is always an angle less than 90. So, minus beta takes you to the fourth quadrant. Okay, that's your minus beta angle. So, cos of alpha times. Is cos beta positive or negative in the fourth quadrant? Positive. Remember, it's all stations to Claremont. It's positive. Cos beta. Sin alpha times. Now, in the fourth quadrant, is sin positive or negative? Negative. Making this positive a negative. Sin. So then we just proven the identity, which is now equal to the right hand side. We just proven the identity, which is cos of alpha plus beta can be written as cos alpha cos beta minus sin alpha sin beta. Okay. Let's look at the next one. Here we got sin alpha plus beta. But remember, what did we prove? We proved that identity, which is cos alpha minus beta can be written as cos of alpha cos beta plus sin alpha sin beta. You must use that identity. Okay. So first we need to get, again, this is what we need to prove. So we need to get our left hand side, which is sin alpha plus beta, looking like cos alpha minus beta. How are we going to do that? How do we change sin to cos? 90 minus, not so. So what do we say? This can be written as sin, sorry, not sin but cos, yes, cos 90 minus alpha plus beta. You all agree that cos alpha, cos 90 minus alpha plus beta is sin alpha plus beta. You all agree with that? Why? Because there's your ratio here. So what we do now is we get rid of the brackets within. We now say it's going to become cos 90 minus alpha minus beta. Okay? So what am I going to make the alpha angle now? What do you notice there? There's minus beta, so hang on. Let's not change this. Let's keep that the same. However, this now will become my alpha angle. You guys understand? By doing that, that is my alpha angle. So that will be alpha minus beta. So then, why do I want it like this? So that I can use this formula here. You guys understand? In the exam, they would give you, given that cos of alpha minus beta is this, derive the formula sine alpha plus beta to be that. Okay. So what do? And I do the expansion. So we go. Cos alpha minus beta can be written as cos alpha. And what is alpha in this case? 90 minus alpha times cos beta plus sine, and what's my alpha in this case? 90 minus alpha times sine beta. Okay. So 90 minus takes you to which quadrant? 90 minus? Fourth. Second. First. Third. Come on, people, man. 90 minus is in your first quadrant. No, you say, yes, I did say third. It was second or first. You said all of the quadrants. Is cos positive or negative in the first quadrant? Positive. So, but changes to sine alpha times cos beta. 90 minus, which quadrant is this in? First. Don't make your first sound like a third. No? First quadrant. Sinus, positive. Changes to cos alpha times sine beta. And there we have just proven that one. This one is worth 4 marks, no? So here we have just proven that sine alpha plus beta can be written as sine alpha cos beta plus cos alpha sine beta. Okay. Are you guys okay with that? Let's carry on with our lives again. And that's of course the last one. Remember, what did we just prove? We proved the formula that stated cos alpha minus beta was equal to cos of alpha cos beta plus sine alpha sine beta. Okay, we just proven that now. Again, we must get this sine, which is the left hand side now, equal to cos. How are we going to do that? How are we going to get sine of alpha minus beta starting with the cos? By saying 90 minus alpha minus beta. What do we do now? Separate, get rid of the brackets within. Okay. Which now gives me cos 90 minus alpha plus beta. Is this minus beta in conformance with this plus beta here? No. You must get it the same. Not so. And how are we going to get it the same? How are we going to get the same? We did it in the first sum. Huh? So it's going to be 90 minus alpha minus beta. Not so. So what is my alpha now? 90 minus alpha. What's my beta now? Negative. Can you see now? It's going to be cos alpha minus beta. Okay. Let's carry on. So cos alpha minus beta can be written as cos of alpha, and what's your alpha in this case? 90 minus alpha times cos of beta is cos minus beta plus sine of alpha, sine 90 minus alpha times cos of beta, sorry, sine of beta, sine minus beta. Okay. Ms. Haas, you okay? What are you busy with? Huh? The PDF. Oh, you're checking if I'm doing it right? Nice, I like it. I like it. I will tell you I don't know what's going on. Don't worry. Right, people, what do you do here? We're going to say 90 minus in which quadrant? First quadrant. The first, yes. It's called positive and negative. Positive. So you change that to sine alpha times. Negative beta is in which quadrant? Fourth. Cos positive and negative? Positive. Cos alpha. Or beta in this case. 90 minus which quadrant? First. Sine positive and negative? Changes to cos alpha. Sine minus beta which quadrant? Fourth. Sine positive and negative? Negative. So sine beta. That negative that's coming from here is going to make this positive. Negative. There's the fourth. The fourth idea. Okay. So what I do is, I'm not was always given the formula sheet. So now we need to memorize the formula. Okay, of course there's many ways of memorizing this formula. Formulas. So what we say is cos alpha plus beta. The cos is CC. Cos. The cos alpha, cos beta. Opposite sign. Minus. Sine alpha, sine beta. So cos is the same. Cos is CC. C, cos, and CC, both. Alright. But what was when this was a minus, then this was a plus. So for cos, the ratios are the same, those together, but the sign is different. With sine, the ratios are different and the signs are the same. So when this was minus, then that was plus. Okay. And of course the other one, which is sine alpha plus beta, ratios are different. So it's sine alpha cos beta. Same sign, opposite sign? Same sign. Which is plus sine beta cos alpha, or cos alpha sine beta. The same thing, no? Cos alpha sine beta. And when this was minus, then that had to be minus as well. Alright, you guys got it? You must remember that because I'm going to forget. No, I'm joking. My favorite topic. After geometry and graphs and okay, always my favorite. No? Right, people, we are on example what now? Example on page 94. Well, the exercise is on page 95. However, this example 1 is on page 94. Right. Compound angle formulas are used to simplify the following example. Simplify the expression. So which one is this? Okay, we first write it down. We just did. We are very lazy. Right, let's pull this down. So you got sine alpha cos beta plus cos alpha sine beta. Which one of the four is it? Is it the sine or the cos one? The sine. The sine the same or opposite? The same. The sign for sine is the same. For cos, not O, it's a CC. Cos is CC, so it's the same ratios. Sine is opposite ratios, but the same sign. Here we got the same ratios but the opposite sign. Must be fair. Not so? You give some and you take some. Not so? Alright, and you guys don't want to give anything in maths, no? You only want to take. Right. So, you don't have to write this down, but I always tell you to write it down. We know that sine alpha cos beta plus sine beta cos alpha is equal to sine alpha plus beta. No? Why? Because at the sine is the same sign. Not so. So if you go with this, what we have here, this will simply be sine. What is my alpha here? 20 plus. What's your beta here? 40. What's 20 plus 40? 16. So hang on. I almost feel like I'm at home now. Special angles, yes. Not so. So now what? What's the size of this angle? Yes, it's going to be 30, 60. 1, 2, 3. What is sine of 60? Opposite over? Hypotenuse. So sine of 60 is going to be root 3 over. People simpler than that you can't. No? You guys understand? Right. Okay, let's do another one. It was number 1. There's a lot you must do now. Number 2. What do we have here now? We got cos 50, cos 140 minus sine 130 sine. People, cos, sine reminds us of what? Cos. Same sign, opposite sign? Opposite sign. Right. These are the questions you must ask yourselves. Okay. But say, hang on. Is alpha the same as alpha and beta? No. Now what? You must make it the same. Okay, I can't still give you the long time to think. You must make it the same. How are we going to make it the same? How are we going to make it the same? Using reduction, yes. The person in the next class is using reduction formula. Make it all acute angles. No? So it become cos 50 times. Now cos of 40 is in which quadrant? Second quadrant. Is cos positive in the second quadrant? How do you get into the second quadrant? So you become cos 180 minus 40. Minus. Which quadrant is 113? Second quadrant. Is sine 180 minus 50 times. Well, what do you notice already here? Getting excited now. We're seeing the link. That's going to be alpha. Not so. Times cos. Which quadrant is that in? Second. So it's 180 plus 40. Sine. Sine. Sorry about that. 180 plus 40. Right. Now what? Simplify. Let's use a reduction here. So it's cos 50 times 180 minus. Which quadrant is that in? Second quadrant. It's cos positive or negative? Negative. So that negative that's coming from here, I'll put B. Okay, we always put it in front. Not so? So, just put this off here. It is off. Okay, so that's going to be negative cos 40. Not so? Minus 180 minus is in which quadrant? Sorry? Second. Is cos positive or negative? Positive. Sine 50 times 180 plus is in which quadrant? Third. Is sine positive or negative? Negative. Now that negative that's going to come from here is going to make this negative positive. Okay. It will be positive, a negative sine 40. So what do I notice now? Do I have a negative sign anywhere there? Make some? No. So what do I have to do? We must get it positive. How do we get that positive? Divide by? Can I divide by negative? Make some? No, why not? Why can't I? Because it's not an equation. It is an expression. Where were you guys when you did quadratics in grade 11? As normal? Absent-minded, no? Right. But anyway, we take our negative as a common factor. We get cos 50 times cos 40 minus sine 50 sine 40. Right, now what? Can you see the resemblance now? Cos alpha, cos beta, minus sine alpha, sine beta. You see that? So what do we do? How do we say this now? This can be then written as, because it's minus, I'm going to use a plus. So what would that now be? Minus cos alpha, which is 50, plus beta, which is 40. What's 50 plus 40? 90. So it's negative cos of 90. What is cos of 90?
Good afternoon, may I have your attention?
Cos.
The inter-society learners that's going
Cos of
to
90?
sex on Sunday.
0.
Please greet Mrs. Benjamin in the classroom now. Correct. Inter-society learners going to sex on Sunday to meet Mrs. Benjamin in the classroom now. That's correct. Diabona Nakabani and Rihanna Grace Julie, can you please report to the office for a collection? And a reminder to all learners, please to wash your hands regularly, especially when you've been to the ladies. Please make sure that you wash your hands thoroughly. We have a stomach bug going around. We do not want to infect each other at school. So please.
We must see who has the stomach bug. They're the people that I must speak to, not so. Those are the people that said, yes. So you need to go to the toilet. Nice. Just hang on. Right? So, 1 minute. Is 1 minute okay? This is the last one. So cos of 3a, cos of a, plus sine of 3a, sine of a. People reminds us of what? Cos. The cos one, eh? Cos, cos, plus sine, sine. So if you look at cos, cos, plus sine, sine. So that what must be in the bracket? Minus. Okay. So I don't need to write it down, eh? You see it? So what do we have? Cos alpha, which is 3a, minus beta, which is a. And what is 3a minus a? It's simple, no? Right, so example 4 and 5 will be done probably not tomorrow but the day thereafter. Okay, for homework. So we're going to spend some probably the whole of next lesson on this. Okay, for homework I would like you guys to do exercise 2. Exercise 2 is number 1.1, 1.3. Number 2 is 2.1, 2.3, 2.5, 2.7. Number 3, 3.1, 3.3, 3.5, 3.7, 3.9. Which means to say, numbers 1, 2 and 3 you must do the odd numbers. People enjoy the rest of your day. Good morning, class. Our next lesson will only be dealing with it. Okay. So please do your homework.